Welcome to part 4 of Competency 13 quiz. In this video, we will continue to work with geometry and composite figures.
Number 16. The sum of the bases of a trapezoid is 36 and its height is 9. If the diagonals of the rhombus are 5 and 3, what is the shaded area? Okay, this is how we need to set this up. We have the area equal to the trapezoid minus the rhombus. Remember, we're cutting out, the white part is cut out. I think in the other videos I mentioned that I didn't realize until students told me. No wonder they were struggling. They honestly thought that the white shape was on top of the trapezoid, and you find out each area and add them together. And I physically had to show them. We cut out the white part is just a hole in the shape. Yeah. You never know how someone is thinking. So what do? We will take what we know to be the area of a trapezoid, which is we have the two bases added together times the height of 9, divide that by 2, minus, for the rhombus, that is 5 times the 3. Remember the diagonals, we multiply those together, and also divide by 2. Okay, so what does that give us? Well, let's just put that in the calculator, and looks like all of our options are halves. Anyway, let's just put the calculator. Now we will have to use parentheses because I do see an order of operations. Well, it might not, but let's do it anyway. So parentheses, I see 36 times 9, divide that by 2, close the parentheses, minus 5 times 3, divide by the 2, close, once I started using parentheses, that would shoot an error. 5 times 3, divide by 2, close parentheses. Take a double look, make sure I didn't make any other errors, push enter, and that is correct. All right, that is the shaded area. Okay, now, number 17. The figure to the right represents which of the following? Okay, obviously it can't be a cone. And I know right up it's a cylinder. I mean, because come on, a cone is going to have a half, some kind of a half shape like this. A cube is going to be 4 squares all laid out, so it can't be a cube. And of course, a perimeter a pyramid has to have, the rectangles laid out correctly, you know. So there's just no way it has to be a cylinder. Okay. I know that's an easy one. I mean, but they're just trying to see if you know the nets of your shape. So if you aren't familiar with any of the nets, the shapes all flattened out, laid out, then it would be a good idea to go get yourself familiarized with that because that's a big thing related to teaching. Okay, number 18. The net of a rectangular prism consists of 6 rectangles. Which one of the following is the correct description of these rectangles? Okay. All right. Let's look at A first. They are all congruent. If all the rectangles were congruent, then we'd have a cube. That would mean, think about it. There's no other way to slice it and dice it. And I'm going to go ahead and mark through that one. But instead of looking at it like this is how I like to look at it. We have the top of our box equal to the bottom of our box. And we have the front of the box equal to the back of the box. And then you have the right side of the box equal to, actually, I would make more mental sense, mind sense, if I said the left side of the box is equal to the right side of the box. And there are 6 sides of a box. So we have, here's a pair, here's a pair, here's a pair. 2, 4, 6. 6 sides. Okay, now let's keep reading. None of them are congruent. Well, yeah, that would be a very weird scalene shape. Okay, some kind of scalene prism, I suppose. 4 of them are congruent. Well, from the way I just described it, wrong answer. D, they are congruent pairs. And that is exactly what I wrote out. Okay. You know, that was kind of a childish way that I did it. Kind of like saying, okay, this one's equal, that one's equal. But that's the best we have, right? Okay. Let's move on to number 19. Number 19. The diagram below shows a regular pentagon TUVWX with its circumscribed circle. Point P is its center. If the perimeter of this pentagon is 120 inches, what is the length of PY to the nearest hundreds? Okay, I have taken the liberty of drawing in a triangle that we can use. First, we know that this distance that I drew for the triangle, okay, that those are going to be congruent, right? So there's a lot going on here, but we need all this information and we can find it just from the fact of the shape itself and this perimeter of 120. First, if we take 120, divide that by 5, we know that each one of these uh, legs or outside sections will be 24. So, oops. And we have 24, 24, 24, 24. Okay, so that means in particular Y, it's the midpoint of our triangle. So that means that each of these is 12. That may come in handy. Now, key Y, that's what we're looking for, that length. We're going to call it X. We're looking for that. So let's put in our X. Okay, we know that. Now, we also know some other things. Well, if we look at our center and we go around our center, we have 360 degrees all the way around. Well, how does that help us? That helps us because each of these triangles that we can draw has a degree measure. Well, how do we get that? Well, that's 360 divided by 5. And that's going to give us 72. Okay, verify that. 360 divided by 5 equals that 72. Okay, we're getting close. Now that triangle that we've drawn, take a look at it. Obviously, it has to be isosceles. There's one thing that we know about isosceles. You've got 2 congruent sides, and the base, where at the base, you're going to have the angles. Well, those 2 angles between the base and the sides, they have to be congruent too, if you recall your properties. So we can actually get one of these angles and use this angle. It's going to be very handy. So let's calculate that. Well, a triangle is 180 degrees. Subtract the 72. Now 108 is both angles together. Okay? So just divide by 2. Divide by 2. Now we know that each of those is 54 degrees. So we have 54. Here, I could actually draw that outside to make it just a little bit clearer. So this angle we know this angle is 54 degrees. That's pretty handy. So we can use what we know about our trig and our triangle. This is what we have. From our angle, we can say opposite over adjacent. All right, so we know tangent of theta equals opposite over the adjacent. You may recall that. We've got everything we need now. We have the tangent of 54 equals the opposite is our x. The adjacent is our 12. And that's just using what we know about one side of our triangle. That's really all we need. Okay, now with a little bit of manipulation, that is by dividing both sides by, multiplying both sides by 12. Okay, if I could actually draw, that would be great. Okay, so these two cancel out. This gives us something viable to put into our calculator real quick so we can get an answer to this length of py. Okay, so what do we need here? We need 12 times, there's our tangent, and 54. Now, here's the thing. I did not double check to see if my calculator was in degrees. I'm going to go ahead and push enter, see if we get something viable. If I don't, then I'll pop over and change my mode, okay? So let's push enter. Okay, we actually got an option that works with a little bit of rounding. Well, it did say hundreds, so that would round to a 2. So C's our option. But let me check my mode. It's the worst time. Yes, I am not in radians. See that? If you got something weird, pop over and see where it's highlighted on degrees. See, it's still highlighted, okay? So then go second mode, you're out. Now, if it didn't work and you didn't get the right value, go back up, capture it. See how it's highlighted? Push enter, enter again, then you should see that proper degree if you didn't see it in the first place, okay? Just in case. All right, let's go to number 20. All right, 20 says, which construction does this represent? Oh, I can see it. Okay, when we're constructing, well, especially from looking at this image, you're going to construct that circle first. You're going to construct the circle. Then from that point on the circle, it could be any point on the circle, you would draw a ray out. Then use that ray to mark. You'd have to have the same distance, okay? You take, and then from this mark, you would create this next. And then that mark, that center dot there, that's when you create your line L of 1, okay? So it would have to be the circle, then the point on the circle, then the ray, then that second point, you would create it out the same distance, you pick a side. So it's like the half circle. Or you could, if you're doing it digitally, you could go all the way around. And then this dot, then you have these two dots. You have Z and the other dot on L1, and that makes L1. So now let's read our given. Given the point Z on the circle, draw the tangent line L at Z. That's kind of close to what I said, and we'll just hold on to that. That could be it. B, given a line L containing the point Z. No, you can't.
that's kind of backwards. It says draw the perpendicular line to Z. No, you have to have that circle involved. Circles together are a huge part of construction and constructing those circles and half circles. So no, I'm going to say that won't work. That isn't viable. Let's look at C. Given a tangent line L to a circle, find the radius of PZ. No. That one, you're getting off of construction. It says which construction that does this represent? That's going out to some other, I'm not sure what that means. Find the radius. No, we know what the radius is the minute we have a circle. So that doesn't make sense. All right. So D, given a radius, okay, PZ, draw the perpendicular bisector. I don't know how that would work. You'd have to have, given the radius PZ, no, that's just doesn't make sense and there's just not enough information there. So D doesn't really work either. I'm going to have to go with A, although the description is not as complete as what I would like. It's the best we have. Okay. All right. So this will be the last question for these quizzes for this competency. And once again, I really appreciate everyone who's watched and the feedback and just your sharing, your liking. You guys are really the best. Thank you so much. And you know what? I hope you all do extremely well on your tests. I'm rooting for you. Happy testing, guys.